Good morning, good afternoon, good evening. Welcome everyone to our second of our faculty lecture series. Just a little housekeeping rules before we begin. You are all currently on mute. That is just out of respect for our faculty that is going to be giving the presentation. We will allow you to unmute yourself during the question and answer period at the end of the event. If you think of any questions throughout the lecture, please feel free to type them in the chat, and we will be sure to address them at the end of the event. I am so happy and thrilled to be introducing Dr. Violet Chen, our professor today, that is going to be giving our second lecture. And Dr. Chen received her PhD from Carnegie Mellon and a bachelor's in applied mathematics and business administration. Her research currently focuses on fairness specifically and related to AI, ethics of AI as well. So Dr. Chen, it is wonderful to have you here with us today. Thank you for being here and thank you for taking the time. I am so looking forward to your event, and I'm even more so looking forward to the questions that we're going to get the answers to. This is a topic that is truly very dear to my heart and one that I often think about. So I'm looking forward to learning a lot from you. So please go ahead and take over.
Thank you, Dina, for the introduction. Hi, everyone. Very happy to be here. Let me share my slides so that we can get started. Does everything look good?
Wonderful. Thank you very much.
All right. So, actually, let me do this. Do you still see my slides? Just making sure.
Yes, we do.
Okay, good. Okay. Hello, everyone again. Welcome to my lecture today. My name is Violet Chen. I'm an assistant professor in information systems and analytics at School of Business here at Stevens. I'm very happy to have this opportunity to share some of my thoughts about responsible artificial intelligence, specifically from the perspective of ethics and algorithmic fairness. As Dina mentioned, I study these topics in my research, so I hope I can use the next 40 minutes to get all of you to be interested in these problems as well. Now, before we dive in, I just want to thank everyone again for joining today on Zoom, probably from different places all over the world. And I hope this lecture will help start your day, wrap it up, or serve as a nice midday break. Okay, so let's start it by looking at some real-world examples to motivate why we need responsible AI. In this lecture, I will draw a distinction between predictive artificial intelligence and generative AI. When I say predictive AI, I will be referring to classical machine learning and deep learning methods that take existing data and make predictions or decisions. And by generative AI, it will be referring to the recent development that we are all familiar with, such as large language models, image and video generation, and AI agents. Now, before generative AI captured all of our attention, machine learning was the powerful method for many years. We can find success stories across many domains. And here I have a few examples where predictive AI impacts our everyday lives. The first one is from American Express, which is a major financial services company known for its credit cards. American Express has been using machine learning to detect fraud. Specifically, they are looking at their millions of card transactions in real time to flag potentially fraudulent activities. These efforts began as early as 2012 when they first deployed segment-specific machine learning models that led to around 40% improvement in detection accuracy. And the company has continued improving its systems. In 2021, it was upgraded to a consolidated global model that handles all market segments together. The next two examples come from healthcare. The publisher Elsevier, which is known for its extensive medical journals and knowledge base, developed ClinicalPath as a clinical decision support support platform that uses natural language processing and machine learning to suggest cancer treatment paths for physicians. In 2019, the platform already had around 85% adherence from clinical staff, meaning that the doctors, they were following the recommendations a lot of the time. Another healthcare application comes from InfraVision. This is a company that developed a tool that uses deep learning to uses a deep learning model to interpret X-rays and CT scans. The deep learning model itself was trained on over 100,000 images, and in 2018, through partnership with over 200 hospitals, their model was already handling over 20,000 scans per day. The final example is from social media. Instagram uses natural language processing to power an anti-bullying filter that automatically identify offensive, hurtful, or abusive comments on the platform. This is a critical undertaking to maintain a healthy online environment, especially to protect vulnerable users such as teenagers who are active on the platform. Now, as we can see, these four applications serve very different purposes. They do share a common tension. That is, these predictive AI, they offer tremendous convenience and value, but it also carries the risks of unfairness or harm. But unfairness, it can be that some groups would benefit less than others from these AI tools. And by harms, it could be the unintentional errors by the AI leading to real-world harms. Now, more recently, generative AI has expanded beyond analyzing existing data to creating new contents and enabling new types of human-AI interaction. Now, here I want to talk about three interesting applications of generative AI. The first one is AI-enhanced personalized learning. Many of you may know this popular language learning app, Duolingo. Duolingo has integrated GPT-4 to introduce new learning activities. One is called role play that allows learners to practice real-world conversations with chatbots in the app. And the other is called Explain My Answer, which uses large language model to give users jargon-free, concise explanations of their mistakes. Beyond the user experience side, generative AI has also helped the company build courses. In 2025 alone, Duolingo built 148 courses with AI assistance. This is a significant speed up compared to that it took them 12 years to build the first 100 courses. The second example I have is AI in the legal field. Law, as we know, is one of the most document-intensive professions. Co-counsel is one example of an AI legal assistant. It is a large language model trained on legal documents. One compelling real-world use case is by this organization, California Innocence Project. This is a nonprofit legal clinic that's dedicated to helping wrongfully convicted people. People at this organization has been using co-counsel to accelerate document reviews and preparation. For example, the time for drafting one client letter dropped from 15 minutes to 1 minute. This has allowed the organization being able to handle more cases and help more people. The third example comes from the research community. There has been expanding efforts to use large language model for forecasting. And specifically, there is a recent paper that proposed a large language model for forecasting infectious disease. A system called Pandemic LLM was proposed, and the key innovation of this new method compared to traditional forecasting tool is the use of large language model allows us to integrate real-time complex non-numerical information to help us forecast more accurately. Taken together, these examples show that generative AI, much like predictive AI, holds significant potential for social good. But these growing applications also raise new ethical questions that we must take seriously. such as the risk of hallucinations, who bears responsibility when AI gets it wrong, and etc. These kind of questions motivate and necessitate responsible AI. Now that we have seen some examples, let's now formally define responsible AI. This responsible AI can be defined as the intentional development and deployment of AI systems that promote societal benefits while minimizing the risk of harms. It represents a fundamental shift from asking, can we build this AI tool, to should we build this AI tool? This question has gained meaningful traction on the global policy level. Just to give a few examples, in 2021, UNESCO issued its recommendation on the ethics of AI, which was unanimously adopted by its 193 member states. In 2023, in the US, the National Institute of Standards and Technology released their AI risk management framework. This gives organizations a practical structure for managing AI risks through the full design, development, use, and evaluation lifecycle. And in 2024, the EU AI Act became the first comprehensive AI regulation. They used a risk-based approach that applies stricter requirements to higher stakes AI applications. These policy guidelines advocate responsible AI for its promises and benefits in multiple aspects. Responsible AI, when done correctly, can help protect people's rights and safety, maximize the positive benefits, enable trust and innovation, and also promote equity and inclusiveness. With responsible AI as our overarching goal, AI ethics actually provides the principled framework for achieving it. In other words, responsible AI rests on a set of foundational ethical pillars. While different frameworks vary in their emphasis, there is strong convergence around 4 core components in AI ethics. And respectively, they are the ones that you see on the slide. So let's go through them one by one. Transparency is about increasing the explainability and interpretability of AI systems and being open about how they work to promote trust and minimize harm. Then fairness means preventing, monitoring, and mitigating unwanted bias and discrimination, and also to ensure fair access to AI and its benefits. Privacy involves protecting personal data through data governance, privacy by design principles, and proper access control throughout the AI lifecycle. Then accountability is about clearly define who is responsible and liable when AI systems produce harmful or undesirable outcomes. In addition, there are two other aspects that are increasingly becoming more important in AI ethics. One of them is safety. That is, AI should avoid foreseeable or unintentional harm. These aspects include security against adversarial attacks. Lastly, human oversight requires maintaining meaningful human involvement in critical AI decisions. Now, these pillars give us a shared vocabulary for talking about what it means to build AI responsibly. And on the next slide, let's try to use them to think through a few brief scenarios. Okay, so you can see 4 brief scenarios. Let's go through them together and try to think about which ethical challenge each one represents before I review the answer. First, facial recognition software is significantly less accurate for darker-skinned women. So this, we can see, definitely involves a fairness issue as the systems performs unequally across demographic groups. And so next one, a medical AI diagnoses cancer but cannot explain why it reached that conclusion, leaving doctors unable to verify or challenge the result. this would be a transparency issue. So without transparency, even an accurate model can become dangerous because the users cannot interrogate its reasoning. Next, an AI chatbot company feeds user conversations back into its training data by default without clear disclosure. This raises both privacy and transparency concerns. As users, we have a right to know how our data is being used. Lastly, an AI-guided weapon misidentifies a target, but the responsibility is unclear across developers, commanders, and manufacturers. This is an accountability and human oversight challenge, and unfortunately, this one is becoming increasingly urgent and relevant as AI is being deployed in higher stakes domains. Okay, now that we have a general understanding on responsible AI and the ethical foundation, for the next part of my lecture, I will focus specifically on fairness to explain further how to address this aspect of AI ethics. So we'll talk about how to define, measure, and attain fairness in AI. And specifically, I'll be focusing on predictive AI. That is the, let's say, the classical machine learning and deep learning methods. Let's start with the source of unfairness. Bias and unfairness can enter at different stages of building a predictive AI system. And we can consider the following 6 stages as a generic pipeline of building a predictive AI model. The process begins with data collection, that is, data needed to train a predictive model is gathered. The data may carry different types of biases. For instance, there may be sampling bias, that is, some groups are underrepresented. Another type is called label bias, meaning that there is some historical discrimination in the ground truth labels themselves. In these cases, a machine learning model trained on these labels may learn to replicate these undesirable discrimination. Some datasets need to go through feature engineering before training. This may involve the removal of sensitive protected attributes such as race and gender. This is known as a type of effort toward fairness via unawareness. A subtle but important note here is that simple removal of these attributes is often insufficient due to the existence of other proxy features. Proxy features are features that are correlated with protected attributes. Such as occupations may be correlated with gender. So even when we have proxy features, even if we remove the sensitive features, there may still be undesirable bias present. During model training, standard algorithms are designed to maximize overall accuracy, so they do not inherently account for fairness, and in many cases, accuracy-seeking models may amplify existing bias patterns. Then at the evaluation and testing stage, a model may look great on the overall aggregate accuracy performance, but this overall performance may mask very different performance rates across demographic groups. Then at deployment, a model that was fair during training and testing can become unfair in real world due to distribution shifts. That is, the patterns in the real-world data no longer matches the training data. And the presence of feedback loops can make things worse, leading to compounded bias over time. Finally, we have the monitoring stage. The emphasis here is that fairness is not a one-time checkpoint. It requires constant auditing after deployment. And in addition, people who do experience unfairness from AI decisions should have a meaningful way to challenge these decisions. Now let's again go through a specific example to understand how these biases can appear more specifically. So here we are revisiting the fraud detection example we saw in the beginning. And let's think through how a company like American Express should account for potential bias when developing a model for fraud detection. At data collection, the data being collected is mainly transaction data. So we should note that transaction data reflects historical spending patterns, which may inherently vary across demographic groups or market segments. At feature engineering, these fraud detection model may remove the sensitive attributes that they are not allowed to use. But even without these sensitive attributes, bias can still present in the data due to the correlation, due to proxy features such as location, merchant types that tend to correlate with demographics. In model training, as we mentioned, if the objective is purely to maximize detection accuracy, it does not consider whether the accuracy or the error rate is actually fair among different customer groups or demographics. At evaluation, the overall accuracy can look strong while hiding the fact that some groups may be experiencing higher false positive rates, meaning that they are facing more frequent incorrect transaction denials. In deployment, these higher false positive rates translate into a real-world inconvenience, as if a customer is getting denied incorrectly more often, that's something the company definitely tries to avoid. And that's exactly why monitoring is essential. We need ongoing audits to ensure the detection remains accurate and fair for all the customers. Now, I hope this example makes fairness feel more tangible to you. It is not just a theoretical concern. It does show up in real-world AI systems that affect people. So let's move on to look at how we can actually formally define and measure fairness. A major strand of research or works on fairness has been looking at parity-based metrics. The idea is that different groups or individuals should be treated equally or similarly by an AI system. To make this concrete, I'll use a running example. We'll come back to in our discussion. The example here is a loan approval, and so consider a company or a bank that is using a machine learning model for making loan decisions. So this is essentially a classification decision to classify applicants into approve or reject. Applicants can belong to two groups, group 1 or group 2. And the applicant is either qualified or disqualified for the loan. There is a large number of parity-based fairness metrics. I'll only describe a few that are best known. The first one is called demographic parity, also known as independence. This is a type of parity-based group fairness definition. The goal here is to equalize the approval rates across groups. Mathematically, this means the probability of being approved from group 1 should be the same as the probability of being approved from group 2. Now, a limitation of this definition is it does not account for the actual qualification differences across groups. Another definition that is more nuanced than demographic parity is equalized odds, also known as separation. Now, this metric considers both the classification decisions and the qualification status. The goal here is to equalize the error rates between groups. Error rates include both true positive rates, namely we want to approve qualified applicants, and false positive rates, which means disqualified applicants are approved. Equalized odds is also a type of parity-based group fairness. And one more parity-based group fairness is called predictive rate parity, also known as calibration. So as you can probably see from the formulas, this one is kind of a reversed way of looking at separation. The goal here is to actually equalize the qualification rates among the approved applicants across groups. So the intuition here is by predictive rate parity, the goal is to make sure an approval has the same level of confidence regardless of which group the applicant belongs to. Now, the last example I want to mention here is individual fairness. This is a more broader way to frame parity-based fairness. And it's kind of like a general principle where the goal is we want to treat similar individuals similarly in an AI model. Now, this is appealing in principle, but it can be challenging to apply in practice because we would need to define a task-specific similarity metric that can actually be computed. So these 4 definitions, they each capture a different intuition about fairness. And depending on the application, multiple of these parity-based parity may be desirable. But an important structural result to note here is in a lot of cases, these parity-based fairness, they cannot be satisfied at the same time. Now, moving on, so we have seen these parity-based fairness, they are centering on how people are being treated by an AI system, but they do not consider the actual outcomes of AI decisions. Another family of fairness definitions is called utility-based fairness, actually focuses on the consequences or the outcomes of decisions. The idea is we would like the benefits from AI to be distributed fairly across people. And we can continue with the loan approval scenario. When a loan decision is made, there is an outcome for the applicant, which is how much utility does the applicant actually receive. So we can expect a qualified applicant who gets approved will gain access to the needed capital, and a qualified applicant who is wrongly rejected misses out on the opportunity. We can use a utility to capture these aggregate benefits and costs. Now, utility-based fairness has largely been developed in economics and philosophy, even before machine learning and AI. So as you may expect, there is also a large number of utility-based fairness definitions as well. And let's only look at a few well-known examples. The first example I have is Gini coefficient. This is a well-known measure from the discussion of income and wealth inequality. It measures inequality in the utility distribution, and a lower Gini coefficient means more equal. So if we are using this metric to evaluate the AI system, the goal is to attain a lower Gini coefficient. Another definition is a utilitarian measure. So this one does not specifically reflect fairness, but it is a meaningful measure of the overall welfare from decision. A utilitarian measure sums up the total utilities from everyone involved in the decisions. And the goal here is we want a higher utilitarian value to pursue a higher overall welfare. The next example is Rawlsian max-min fairness. This is perhaps one of the best known fairness specific metric. This was proposed by the philosopher John Rawls. And the idea is to emphasize the disadvantaged people in the decisions. Rawlsian max-min fairness measures utility of the worst of individual. And by making max-min fairness higher, we are essentially trying to give more priority to the disadvantaged people. And finally, I want to introduce alpha fairness. This is a family of measures that essentially generalizes utilitarian measure and max-min fairness. So it stretches from utilitarian to max-min through a parameter alpha, whose value can be chosen by the user to attain different levels of trade-off between the two extreme points. Now, as utility-based fairness focuses on the decision outcomes, it often complements parity-based fairness in a nice way to extend from just making the decisions fair to actually ensure the decisions are leading to fair results. So now that we have seen some examples of how to measure fairness, let's shift here and talk about how to actually use these fairness measures to build a fair predictive AI system, specifically a machine learning model. Fair machine learning methods generally fall into 3 categories based on where in the pipeline you intervene. The first is called pre-processing. That is to fix the data before the model sees it. So the goal is to transform training data to remove or reduce bias. Some examples of pre-processing techniques include reweighting samples or resampling the training set for better group balance, or to learn a fair representation of data that removes demographic signals. The advantages of pre-processing is that these methods are model agnostic. That is, a pre-processed data that's free of bias can work with any downstream training algorithm. The downside is through pre-processing, we may lose some useful information that was in the data. And as we mentioned, there may still be proxy features that can leak bias. These type of methods is the best choice when we have access to the data, but not necessarily the training pipeline. The second type is in-processing, which is to fix the training process itself. This means to modify the training formulation to balance fairness and accuracy directly. Example methods include a fairness penalty regularization term, or to add some constraints to reflect our requirement for fairness. The advantage of these methods is that we are directly optimizing the balance between fairness and accuracy. Now, the downside, as you may expect, is that these modifications to the training pipeline is model specific, and they may increase the computational cost of training machine learning models. These in-processing methods works the best when we are building a model from scratch with full control over the training process. The third type is post-processing. That is to fix the output after the model has already been trained. And common approaches include threshold adjustment, where we can set up group-specific decision thresholds to equalize error rates, and score calibration. The advantage here is post-processing is similarly model agnostic, just as pre-processing. And also similarly, we do not need access to the training model. And post-processing approaches also tend to be very fast. The disadvantage is that it has limited flexibility. And of course, we cannot fix biases that are inherent to the training model. Post-processing works is especially useful when a team is using a vendor or proprietary AI system or machine learning model that they cannot modify, but they want to impose fairness on the outputs. Now, to tie everything together, we have talked about fairness. I want to continue with a real-world case. Now, this case study is about addressing racial bias in a prediction algorithm for healthcare. This was discussed in a 2019 paper published in Science. The problem setting is many hospitals are using algorithmic risk score to decide whether to enroll patients in care management. That is, there are programs that gives high-risk patients additional follow-up care and resources. So the predictive algorithm needs to generate a risk score for each patient. Then the decision is to decide, using these risk scores, what is the threshold we should apply on the scores to decide which patients to refer to a management program. And the system has potentially broad impacts as it was deployed to roughly 200 million people in the US. In this study, the data came from a primary care cohort at a hospital from the year 2013 to 2015. The data includes some of these key information about patients, such as their insurance claims, demographic, diagnosis, lab tests, and medication records. For model development, the risk score prediction algorithm was trained using supervised learning to predict a specific outcome. That is to predict the total annual healthcare cost as a proxy for a person's medical need. And then, as I mentioned, the decision is to choose a risk score cutoff to decide which patients should be enrolled. Now, here is where the bias entered. In the study, the researchers found that at the same risk score, Black patients were significantly sicker than white patients. For example, they had more active chronic conditions, yet they were less likely to be referred to the care program. Upon examining the algorithm, the research team identified the root cause. The root cause is that the cost that is being predicted in the algorithm is a biased proxy for need. Is a biased proxy in the sense that because Black patients on average have less access to healthcare, they tend to incur lower costs even when they are equally or more ill. So in other words, the model learned to underestimate the need of Black patients because their cost didn't truly reflect their health status. Now, these biases indicate we need a fairness-aware prediction method. In the paper, the researchers demonstrated the use of a pre-processing approach. That is to change the label that is being predicted in the risk prediction model. Instead of predicting actual medical cost, they are replacing the cost with some direct measures of health, such as the number of active chronic conditions or avoidable healthcare costs. And then the same model is retrained on these reselected target labels. With this pre-processing technique, the effects were very encouraging. We can see a large decrease in the disparity. The disparity in risk scores was reduced by around 84%, and the share of Black patients that were identified for actual care rose from only 17% to 46%. Okay. So that case wraps up what I want to share about fairness in predictive AI. And I hope that these couple of slides have demonstrated that there has been a lot of efforts towards making these classical AI methods fair. So next time you develop a predictive machine learning model or AI model, I encourage you all to think about fairness and see if there's already an existing tool that can easily make your algorithm more fair. Now, I have a few more slides left. For the last part, I want us to fast forward into the current stage of AI we are in to talk about what are some new fairness and access challenges that are brought by these powerful generative AI tools. Now, as generative AI, what they do is to create new contents. So it's no longer just about making decisions on existing data. So it brought it essentially makes being ethical and fair a lot more challenging. So let's see two concrete examples of observed biases in these systems. In large language models, studies have found that the generated text has some gender-related bias. For example, they would often associate women with domestic roles while men with professional leadership roles. And in image and video generation, the generated contents similarly reinforce gender stereotypes or use racialized defaults in the physical appearances. There are ongoing efforts towards addressing these biases in generative AI. For instance, fairness concepts specifically for Gen AI have been proposed, such as representation fairness, which seeks a balanced demographic representation in the outputs, or quality fairness that emphasizes the output quality from a generative AI model should be equal across groups. Now, there's still a long way to go with measuring and characterizing fairness in generative AI, and several structural challenges with these systems make attaining fairness particularly challenging. For instance, there is prompt sensitivity, where we may have a trivial word change leading to drastically different performance from the drastically different distribution of the outputs, which could make systematic auditing very hard. And second challenge is the absence of ground truth. Unlike a classical machine learning application such as fraud detection, where we know what the correct answers are, in many generative AI cases, it is unclear what a fair distribution of outputs should even look like. And then lastly, there is the bias in reasoning that should also be addressed. So when we say we want to make generative AI fair and bias-free, it is not just about the output, but we also want to try to correct biases in the reasoning itself. Now, another increasingly powerful and attractive AI tool is agentic AI or AI agents. Now, they are doing even more than large language models or image generation. These AI agents are actually plan and act autonomously with minimal human oversight. Now, this shift raises a qualitatively new set of ethical challenges. Now, to see why, let's look at this table quickly. We can see this table tries to compare what are the differences across these three types of AI. In predictive AI, which is what we began with, the goal is just to predict labels. And the biased predictions, they are only acting as adversary. So even when the predictions are biased, human users still have lots of opportunities to correct them. Then generative AI is generating contents. Here, the harmful outputs may have a more direct interaction with users, as it may mislead users to make incorrect decisions. But the human is still largely in the loop at the point of final actions. Agentic AI is different because it plans and acts and executes actions on extended tasks with minimal human involvement. So the harms it potentially can cause may happen without human knowing about them. Now, with this new set of AI tools, I want to highlight a few key ethical challenges that are still largely open nowadays. First is about misalignment and harm. That is, the AI models may strategically deceive operators, and there have also been real-world incidents of AI coding tools being used in cyber attacks. Next one is the oversight paradox. One proposed solution to increase monitoring and supervision of AI agents is to actually have a guardian agent to monitor other agents. But this, as you can see, it creates an infinite loop almost. There's the question of who should monitor these guardian agents. And more fundamentally, we have this challenge is as automation grows, the error consequences rise while our human oversight capacity is shrinking. Then finally, there is the risk coming from multi-agent systems. The miscoordination, conflict, and collusion among agents could make it even harder to use these tools ethically. And single agent safety does not immediately transfer to safety in the multi-agent systems. Now, all these challenges, they don't have clean solutions yet, and they are actively shaping nowadays the AI governance and policy conversations around the world. So in the end, I want to close by looking at how some AI builders are doing responsible AI. So this table here, I won't get into too many details, but here I went to the 3 leading AI builders and found what they say they are doing in responsible AI. So we can see that all of these companies, they are making an effort to tell their users that we are taking responsible and safe AI seriously, and they are coming up with a lot of principles and frameworks to guide the process. But overall, the conversation is very much happening at this moment, and we don't really know what is the right way to make AI, especially nowadays, the generative and agentic AI responsible and ethical. And that brings me to the end of my presentation. We've covered a lot of ground. We began with how AI creates value in the real world, thus necessitating responsible AI. And then we move on to the ethics and mathematics of fairness. And lastly, we talked about some emerging challenges in AI nowadays. And I hope this has given you something to think about and reflect on. That's all with what I will say. I look forward to hear about your questions. Thank you so much.
Dr. Chen, thank you so much for this amazing lecture. I personally learned a lot, and this is a topic that is incredibly important. And I am truly glad that our School of Business has done quite a deep dive in this topic, whether it is from the research that faculty like you are doing or the management of AI program that is offered by the School of Business along with other programs as well. We do have some questions, certainly. I'm going to ask that all questions be related directly to the topic at hand, please, out of respect for our faculty members' time. So if you do have questions, you can feel free to raise your virtual hand and we will call upon you, or please make sure that you write the question in the chat. I know, Dr. Zermulin, you said that you were going to ask the first question. Dr. Zermulin is our Associate Dean for the School of Business and Professor of Information Systems as well in the School of Business. Dr. Zermulin, please go ahead.
Thank you very much. And Violet, fascinating talk. I want to pick up on a question that Boris Minkin put in the chat. He asked, who's responsible if different groups or individuals are not treated equally? Coming back to the earlier examples about predictive AI, is it the humans? Is it the AI? Is it MX management? So zooming out from this a little bit, right? There are companies that are developing AI solutions, and there are companies that are basically buying them and deploying them. Where do you think the responsibility for ethical use of AI and the ethical configuration of AI sits? Is it with the vendors? Is it with the adopters? What are your thoughts on that?
Yeah, that's definitely a very important question. And in fact, that's one question I it also popped up in my mind when I was preparing the presentation today. And I think my short answer to that is ideally, everyone should have their share of responsibility to making AI ethical. So if it's a company that's building an AI tool, on their side, they should make an effort to at least make an intentional effort to correct some of the biases that they know do present in the data. There's always going to be bias or unfairness that we don't know they even present. So those are kind of harder questions to deal with. But for companies building AI, I think there is a responsibility that they recognize that the presence of these issues and make an effort to address them. Then for users of, let's say, an AI tool, if a company is using, not necessarily a company, but if, let's say, a company or organization is using an existing AI tool to make some further decisions, how they use it also have fairness and ethics consequences. So when they use it, I think it's also, they also have a responsibility to kind of reflect more carefully on the potential impacts from their use. And then there's a lot of things that can be done to audit the usage more carefully and to maybe have a secondary layer to double check if the AI predictions or decisions make sense, or if do we need an actual layer, some adjustments to correct these undesirable results. So that's how I would answer is, I think, just to wrap it up, I think each layer in the, let's say, the AI lifecycle has their own responsibility, and the kind of what that responsibility is, it's going to vary depending on what role you are playing.
Very good. I see we have a hand up by Peter Science. If Peter, if you would like to ask your question live.
Sure. Hi, my name's Peter, and I'm a doctoral student studying AI adoption. So thank you for your presentation. It's very informative. I'm interested in how, so I think there's large companies, right? And they can be pro doing things ethically and fairly or not, right? But theoretically, they have the resources to pursue that and give it a fair shot if they wanted to do that. It's also my belief that organizations that have AI, maybe I'm incorrect in saying this, but are going to be more competitive, where you have smaller organizations or medium-sized ones that might want to adopt it or are adopting it, maybe developing tools, but probably more using it. And they might just have enough resources just to attempt to use it and actually not be like, is it even working, right? Let alone do the fairness and ethical, all that stuff, because it's going to require more resources. So my question is, I know the answer is obvious, like how can they, do that? Obviously it's education, they should learn about it, but if they have low resources, that's kind of a difficult thing, getting that extra education as well as hiring people that have that expertise. Mm-hmm. So how do these smaller organizations kind of deal with this ethical fairness thing if they're just trying to compete? So they might be like, oh, I'm not making out 50% improvement. That's good. It's kind of biased, but like we need to compete, right? And we would like to do that, but we don't have the resources to do that. Sorry for that long thing. That's my question.
Yeah. I definitely appreciate the question, and I think it's I like the distinction you are making between these larger organizations that people know about versus the smaller organizations that are more they are trying to rely on this existing AI to make some improvement. So I think from my point of view, I actually believe the smaller organizations and companies, they have their own advantage when it comes to make their AI use more ethical and responsible. My argument is, or this is not fully thought out, but this is kind of my intuitive argument, is these smaller organizations, they would understand their needs and their let's say usage scenarios maybe a little bit better than larger companies. Smaller organizations, when they try to use AI, it might be a very concrete task. And from my knowledge and experience with studying fairness in machine learning and fairness in AI, I think definitely for fairness, a lot of times the challenges you see with fairness is kind of very specific. It's not something that's experienced by all the users of the system, but it's experienced by sometimes a very small group. Or a lot of times you only hear about this unfairness through anecdotes, through hearing people's experience. So in that sense, I can see how a big organization, they may actually be more likely to not know about these fairness or ethical challenges. So in that way, even if they have the resource or tool to address those issues because they don't know about them, nothing is done. But in smaller organizations, when they are looking to AI as a way to improve their current operations, they may already know some potential issues, potential negative impacts that can result from incorrect AI usage. So this gives them an edge even before thinking about how to use an AI. Then when it comes to how they can, make an AI tool responsible and ethical, I think there's a lot of existing softwares or methods out there. So even for, let's say, smaller organizations, they may have for example, they bought an AI model from some other bigger companies. then one thing they can definitely do is to look at what data they're putting in the model, kind of like a pre-processing approach, or a post-processing approach is to look at the results from the AI model and then maybe perhaps do a secondary or even third layer of check within their own organizations to figure out what is a framework that makes sense for their specific applications.
Okay, thank you. I think that there's a lot going on there, and I think you bring a really good point of like actually they might have advantages over thank you so much. By the way,
thank you for your question.
LinkedIn in the chat because I am looking for people to interview for my dissertation at some point. So if you guys want to friend me, that would be very appreciated. Thank you for your time.
So thank you, Peter. And I do want to point out that something that we did last time and that I hope we're going to do this time again, if we don't get to your question in the time that we have in the session, we will record an answer to your question afterwards and add it to the recorded video of this session. We have a couple of people that have raised their hand. Marvin Lomo was the next person that raised their hand. Marvin, if you want to go ahead and ask a question.
Thank you, Professor. I'm Marvin. I'm also a PhD in North Carolina, also preparing for my ISA submissions. I think we all know what's happening here. I have a question regarding the accountability and clarifying attribution of responsibility in decision making with AI. I'm looking at something similar. Are you trying to apply attribution theory to understand how people understand and people conceptualize like who is responsible for decision making in the context of human AI decision, when you're making AI augmented decision making, basically, right? Mm-hmm. So this is like what I'm working towards like, in my IC submission. My question to you is just broadly speaking, the idea of like how do you conceptualize the idea of attribution of responsibility in human AI decision making? That's what I want to know your thoughts on. That's my first question. My second question is regarding privacy and whether you think that like the design of an algorithm can be a privacy harm. Like just those are my two questions. Thank you.
Mm-hmm. Yeah. So for the first question about the accountability, attribution of responsibility in, let's say, a human AI collaboration type of scenario, unfortunately, my insight for that is not going to be a lot because that's not personally my area of expertise. But I do know there is a large amount of work that has already been done in this setup. So I definitely encourage you to, just search broadly in the literature to look for some, there's going to be many, but I think you will definitely find some frameworks that are already established for framing accountability in human AI collaboration. And I would say look maybe into the computer science literature where a lot of these discussions have happened. And especially, in the last couple of years. And for your second question, I believe is about, is there ways to make an algorithm private? So it's privacy promoting or privacy harming? Which way?
So privacy harming, basically, like I'm looking at algorithmic design, right? And privacy, like, and the implications for privacy, right? Mm-hmm. Yes, that's my main question.
Yeah, answer to that would be yes as well, and that's precisely why people are studying privacy as an important task in the in the field. And I would say in general, if you do not try to be private, there are lots of ways that the algorithm can harm privacy because all these machine learning and AI models fundamentally they use data. So if we don't do anything about the data it's in some ways somewhat easy to figure out what the underlying data is. So if you're looking for examples of a privacy harming algorithm, I think the examples of that, maybe we can find scenarios of data leak. I'm not saying the data leak is due to algorithmic design, but it's kind of like it's due to some gaps in maybe how the algorithm is being used. And similarly, perhaps you can find examples of actual algorithm due to the incorrect design leading to leaks of data. And I would say the opposite side is maybe the more challenging task is we know the privacy by kind of the nature of these algorithms is using data. So it has the risk of harming privacy and leaking data. Now, how can we address that issue? How can we make an algorithm actually private?
Wonderful. So we're at the top of the hour, but Philip Abruzzi has had his hand up for quite a while. So I want to let's reward his patience. And I do want to give a shout out to everybody that had put a question in the chat. Mohammed, Melusi, Janki, Timo, Iran, and Muhammad. We will get to your questions. If you look at the video recording of this that we will post later in this week, you will see a segment where your questions are specifically addressed. But for now, let's go to Philip.
Yes, thank you very much. A lifelong learner here. Stevens graduate in the 1900s, trying to stay current with some things. I guess the one question I have for Dr. Chen would be going back to her earlier example, a company purchasing in an AI system to improve their operations. And I'm wondering, and this may be naive, but I'm wondering, why is it not the part of the due diligence of the company doing the purchasing to actually take that, what they're going to be buying, and use it on a random cohort of their database, and then actually examine just how well it does for all the attributes that are expected from this. It would seem that would be part of the purchase agreement, that the AI system has to be fit for purpose, and it's not just to do the function that's bright and shiny and right up there in front of you, but also all the fairness models that go along with it. So, and that, to me, that's just an ordinary business thing. It's done, all kinds of engineering projects and such. So I'm just, what are your thoughts on that, Dr. Chen?
Yeah, thank you for the question. I have to say, I don't have enough experience in the industry actually learning about how this kind of purchasing agreement happens to provide a very deep insight into that. But I personally would agree with what you mentioned, is before a company decides to buy an AI tool, I think it's not just about looking at kind of the marketing materials of the AI to understand what it can do. We actually need to understand, as a potential customer, we need to know, is this AI tool going to be useful for the type of problem I want to use it to solve. Again, I wish I can share more, but I feel like I don't have sufficient experience to provide more insights. But I guess even sometimes if you think about how maybe we are using these large language model tools every day, sometimes I guess before we decide to use it, we don't think that much about is it specifically suitable for the task we have in mind. But it's just there is a tool out there, let's try it out and see what happens.
You never know which wrong road the test drive may go down. That's the thought on that. I mean, if it's think about it that way. So thank you very much.
Mm-hmm. I think major AI companies are actively building and improving safety features, but whether these generic safety features are sufficient or even useful for AI and education is somewhat unclear. For instance, a content safety filter designed for general use may not account for age-appropriate educational content or the specific ways students interact with AI. To me, nowadays, AI is growing more individualized. The same large language model or AI agent can lead to very different impacts depending on how people decide to apply them. What this means is that the responsibility to make AI and its impacts safe needs to be shared between AI builders and users. While the companies should be accountable for following safety principles as they claim, we as users will probably always have our shares of accountability to handle. such as educators need to decide how and when to introduce AI tools in their classrooms and setting guardrails for student use. This is a valid concern with explainable AI, and I think these potential strategic behaviors are not invalidating explainability by itself. It's a real trade-off. That is, more transparency does give adversarial actors more information, but the alternative, keeping AI decisions opaque, also creates its own serious problems. The possibility of strategic interaction with AI indicates the need for additional safeguards in AI-based decisions. For example, consider the AI-supported loan processing example. With full explainability, an applicant likely know how their application can be altered to get approved. With expectations of potential dishonest applications, the loan provider may implement additional information verification steps to identify potential dishonest cases. In this scenario, explainable AI itself is not enough. We must accompany explainable AI with process changes as well. There is indeed a tough balance to find between regulating AI and developing AI. This regulatory level lag is not specific to AI. I'd argue that it applies to all types of innovation. We saw the same dynamic with, for instance, social media, with financial technology. Regulation follows innovation and it gradually catches up. Although it is infeasible to regulate every aspect of AI, I think there are always ethical norms that we can use as a fundamental guidance. For example, the principle of do no harm is almost always applicable. Even before we know what generative AI or agentic AI can do, we know that these models should not cause harms for society. When regulation evolves with innovation, I think the core principles in these regulations often remain persistent. And that is encouraging because it means even as AI evolves in ways we can't fully predict, we are not starting from scratch. We have the ethical foundations to build on. As fairness does not have a unique representation, I do think it will always depend on the application context and the decision team's choices. That is, as builders or users of AI, we need to make a call about what fairness is in our specific context. This is exactly why I talk about multiple fairness definitions in the presentation today. There is not one right way to formalize fairness, and choosing between the different fairness metrics and definitions is a judgment call that should be shaped by the application and its stakeholders. On the other hand, I think AI can be almost fully fair in the sense that it has the ability to adhere to well-specified fairness constraints or be able to provide bias-free reasoning that does not carry existing stereotypes. Fairness as a concept comes from philosophy and has deep theoretical roots. It's also not the only term used in the space. Justice and equity are closely related concepts that also appear throughout literature. The reason fairness has become the dominant expression in AI and machine learning, in my opinion, is because this term is generally accessible and it is intuitive without feeling too domain specific. And to your second point, there absolutely are formal standards and norms behind fairness. The definitions I talk about today are all grounded in ethical norms. For instance, Rawlsian Maximin fairness is grounded in Rawls' theory of justice. I think, yes, to some degree, our understanding of ethics, privacy, and fairness has not kept pace with how rapidly AI has expanded in our daily life. But I think that gap is somewhat expected or perhaps even acceptable. Ethical challenges are difficult to address without first understanding what they are. And that understanding often comes from actually observing real deployed systems where issues may emerge. The research community and the industry has both worked hard to address these problems as they surface. The healthcare bias case we discussed is a great example. Now, these learnings about fairness and ethics are building a foundation that will be useful for guiding ongoing AI integration into our daily lives. And I'd also say that many times when we don't hear about ethics, privacy, or fairness issues, it probably means that no serious incidents have occurred. The hope and the goal of the field of responsible AI is to catch issues before they cause harms. My answer is yes, and I think that analogy is a great one. In predictive AI, I would say this shift has already started. There are now well understood and widely accepted frameworks for fair predictive AI. And in many systems, the developing teams already report fairness-related performance metrics alongside accuracy metrics. So it's becoming part of the standard evaluation pipeline. Now, in this new wave of generative AI, as we discussed, there are fresh challenges that are still largely open. So we are not fully there yet in terms of fairness in generative AI methodology, but the awareness is definitely there. Just like how cybersecurity became widely adopted in the early 2000s, I believe the field is moving from treating fairness and ethics as an optional add-on to recognizing it as something that should be embedded from the start. As well studied as fairness is, there are still many open challenges. For instance, there is still no consensus on what being fair should mean in business context. Another challenge is that most fairness methods today focus on the prediction step and the decision step separately. But in practice, predictions feed into decisions. Therefore, the fairness of the overall decision pipeline may look very different for the fairness in individual stages. At Stevens, we have many faculty and students working on different aspects of ethical AI. One project I am working on is fairness in prediction-based decisions, where our goal is to study how to enforce or implement end-to-end fairness across the full pipeline through prediction model output to the final decision outcomes. At School of Business, we also have faculty working on fair lending problems, and I know that in computer science, we have people working on fairness in large language models. So overall, at Stevens, we are actively trying to contribute to multiple fronts of research on responsible AI.
So thank you, everybody, for their questions. And thank you in particular, Dr. Chen, for your wonderful presentation today. I'm going to hand it back to Mrs. Karos to close out our session.
Thank you very much again, Dr. Chen, for this amazing lecture today, and Dr. Zermulin for chiming in as well, and to everyone who asked the questions today. As a collaboration between the Office of Graduate Education and our esteemed School of Business, we thank you all for being here. And of course, lifelong learning is definitely a pursuit, and it's one that everybody needs to be following, especially right now in the age of AI, where things are changing every single day. So certainly, I think upskilling and making sure that we have the right information underneath our belt to be able to properly do our jobs and figure out all the things that we need to know in order to bring these AI systems within our companies. I think that's incredibly important. Whether you are a manager or whether you are doing the work, you have to understand what you're dealing with. And I am super happy that Stevens Institute of Technology has taken this upon themselves to make sure that we are leading this task. We are leading this education. Every single one of our 58 master's degree programs has now AI in it. So every single one of our programs offers AI education. It doesn't mean that your programs or your expertise is no longer going to be needed. We talked about this in the last lecture with computer science. Of course, we need computer scientists still, but you need to know how that's going to now be impacted with AI. and how you can use it to your advantage. So as a thank you for all of you for being here today, since I am the Director of Graduate Admissions, I need to put in a plug for this. Thank you for being here. And if you are interested in applying to a graduate program at Stevens Institute of Technology, of course, we will be offering you an application fee waiver as a thank you for being with us and for spending this time with us. I am going to put in the chat again the recording for last lecture that Dr. Zermulin started the events with, and Dr. Chen's lecture will also be added once it's edited, and once we get some of the questions to the answers that were in the chat, will be added to that same page. You will all be receiving an email. Now, do keep in mind that if you attend 4 out of our 6 lectures, it doesn't mean that you shouldn't be attending all 6, but if you attend 4 out of our 6 lectures, you will receive a LinkedIn badge from from Stevens Institute of Technology, indicating that you have indeed attended these lectures. So I hope this helps all of you in in whatever you do as well. And I hope that we will be in contact very soon. And until I see you next week for yet another lecture, and I believe next week's lecture is going to be AI in Finance, Rewiring Robo-Advising for Autonomous Portfolios. And that's going to be by our very own Dr. Zachary Feinstein. So I do appreciate your time for being here with us today. And I'll see you next week. Thank you. Thank you all so much. Take care.